Good afternoon, everyone, and welcome to our Teacher Professional Development session for Earth Science Week. It has been an amazing day of some fabulous programs, and once again, a big thank you to Geoscience Australia for supporting the Earth Science Week virtual excursions today, enabling all of these programs to be delivered for free. And a big thank you to Geoscience Australia for coordinating all of our wonderful speakers that we have today. So I'm going to hand over to Dom from Geoscience Australia that is going to get our afternoon's program started.
Thanks very much, Karen. Hello, everyone. Happy Earth Science Week. Welcome to this afternoon's session. As Karen said, my name is Dom. I'm the Education Centre Coordinator here at Geoscience Australia. And in Canberra here, we operate on Ngunnawal and Ngambri country. And I'd just like to take a moment for us all to remember that wherever we are in Australia, in all different countries, in earth science, what we do is we continuing a very ancient practice of earth science that has been going on for thousands and thousands of years. And so I'd just like to pay my respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people. So thank you for joining us this afternoon for this teacher professional development session. We've organised some of the major plays in earth science education all to be in one place this afternoon, one big virtual room to have a bit of fun, share with you a bit about what they do and what they can offer you as well, and provide you with the opportunity for you to ask any questions of them. In the digital room, we have Hannah from AusEarthEd. We've got Jet and Adam from Core Learning Foundation. We've got Philip from Teacher Earth Science Education Program. And we've got Shona from Geoscience Australia's Education and Outreach Program as well. Now, teachers, our overarching aim for this afternoon is to expose you to some of the great resources and activities from each of these organisations and the people behind them. And as I said before, just to show you how we can all be of support to you in the classroom. Everybody here does something unique for earth science education, but together we make up an education ecosystem, you could call it, that is very, very likely to have something to offer you in terms of resources or services or teacher PD. So without any further ado, we're going to kick off this little round robin of Teacher PL with Shona from Geoscience Australia.
Hello, thanks Dom, and thanks Karen for that introduction. And welcome everybody who's online with us this afternoon. I'm sure it's been a big day so far, and we hope we'll add something of value to it at the latter part of it. So I'm joining you here from Geoscience Australia. It's an organisation based in Canberra, and if you came in our front door, you'd see, as in these images, rock and mineral collection on display. And if you came in a bit further, you'd walk into our education centre with those big square red squares on the floor. And Dom and I are literally in a room just next door to that right now. So that's where we're coming to you from this afternoon. Geoscience Australia is our national organisation to supply information about geology and geography of Australia. And that's a really, really wide brief these days. It involves everything from Landsat satellite imagery delivery to the country, understanding our rocks and minerals underground, understanding groundwater and even surface water through the satellite imagery, community safety and earthquake monitoring in particular based here, looking at marine jurisdiction, mapping the seabed all the way down to Antarctica, and much, much more. So we're a very wide-ranging remit these days. The education team is just a small part of that, and the four of us are involved with hosting students in our education centre that you just saw, providing education resources to support earth science education around the country, and teacher professional learning, and that's what we're here for this afternoon. But rather than doing a sort of quick romp around all our different resources, we're going to showcase two of them and highlight what they involve. And the first one is an activity that's all written up, ready to download, called Why Are River Pebbles Round? And at this point, we're going to go off the PowerPoint and I'm going to see if I can show you some things. So as we know, many students are great collectors. They love collecting pebbles and rocks and all sorts of things. And they would have noticed that often river pebbles or pebbles off the beach, if you have those there, are rounded off and smoothed. So this is an activity, an inquiry activity, where we're trying to think about the why behind this smoothing off that we see of some rocks. Now, if we go back, we're going to think about this as an origin story. What would that rock perhaps have come from? So maybe it was originally a rock like this, a piece of granite. And we can see when we look at this that it's quite sharp and angular. And if we were to try and do a series of activities to see what makes it round off, it's going to be a pretty laborious and long process because this is a pretty tough rock. So instead of using lumps of granite, we're going to use sugar lumps to represent our rocks through a series of activities. So we can sort of see sugar lumps, they've got sharp pointy corners, they've got sharp edges, they're certainly not rounded when they start off. Of course, these days, a sugar cube is actually not a cube as such, but there we go. So we do this with our school groups sometimes in the Education Centre as a quick and dirty version of this, and there's a more detailed written up version. But the quick and dirty might be, well, have a look. What does it look like? How can we describe and observe our sugar cube? In the classroom, you can be measuring, weighing, drawing, and recording all sorts of information about the before situation. And then we're going to imagine that our sugar cube is like our rock. It's perhaps been broken off up in the high mountains somewhere up off the edge of a cliff, and it falls down into the upper course of a river up in the hills. So a container of some sort is going to represent our riverbed. In it goes, pop the lid on, and then imagine a great big storm, rain's falling, you've got lots of water then flowing down the stream, and that is going to impact on our container. So we start shaking. Remember to breathe. And it's a great one for getting kids out to have a go and do the shaking for themselves. That little blighter that's been talking at the front or back all day, you can get them doing something. After however many shakes, depends, we can reveal what's happened. We go looking for the original sugar cube. And in this case, I've got several other ones in the bottom there. And we can re-observe. Is it the same shape? What is the precise language that we can ask students to use to describe the changes? And we need to be thinking about rounding off. We no longer have the sharp edges. What has happened to the overall volume? If you're doing the more detailed version, you might be weighing, but you can see getting smaller and getting smaller. And, you know, down in the bottom of the container, there's a whole load of smaller parts and there's sugar dust. If you had some real river sediment and pebbles, you can compare the two and see which one, if it's a good sort of analogy for what we're looking at. So that's the quick version of showing how you might get from a rough rock to a smooth one. But we've also got in the write-up a more detailed version where you can be even more systematic about it. And in this case, you might take your sugar cubes and you might be also crossing over with your maths. You might be counting and then marking up all of the edges. You could be marking up all of the corners. There's red dots in each of these corners. We've even got one of the faces coloured in. And then those sugar cubes go into the container and get shaken around for a systematic number of shakes, 50 shakes, 100 shakes, 200 shakes, and that information gets recorded. Oh, and this is the write-up, but this is part of the write-up where there's 40 shakes and they repeat and repeat. That's the activity that we have, but that's as a bit of a closed inquiry. You can extend that to your students to say, well, what are the other variables that we can consider? What happens if we only shake up and down, or if we shake in different directions? What happens if we have more or fewer sugar cubes in there together? What happens if you add a marble in at the same time? So many options for students to extend this inquiry. You can imagine a whole classroom, can't you, of that shaking going on all around the room with the earplugs. That's probably the best way to go. So that's an activity that is available for download. It's also available as a short video, as a bit of an explanation. So particularly great if you have a student that was away for your class or you wanted to provide a summary version of it. There's a video amongst our whole range of videos that are available. We've got a YouTube channel and on our web pages itself. So that's the first activity I wanted to showcase. But the second one is actually kicking off from the thought that here at Geoscience Australia, there's been lots and lots of talk recently about critical minerals. It's the buzzword with government. And but the thing is, it's like, well, how can we relate that into the school level? But there's also, for the Australian curriculum version 9, the word minerals been introduced at year 3 level. And that is something that's a bit of a challenge, and it may or may not filter through to every state curricula in quite the same way. But we took a step back and thought, well, how can we create a resource that's a kicking off point or a stimulus for this topic that involves that word mineral? And we ended up with the idea of meaningful minerals represented in a wacky new poster. So in fact, you know, this is a folded up version. This is the whole A1 printed poster. And you are absolutely welcome to write to us and ask for a poster pack, and we can supply a set of our posters that we have available in print. So the point of this poster is to represent elements, because we have to mention elements, because most of what's listed as critical minerals are actually elements. There is a mineral for each element that would contain that element. So there could be multiple minerals. We just picked one and picked some that are quite brightly coloured. And then we've got the snaky, woolly lines, if you like, of colours leading to 6 major usage types for these minerals, particularly usage in modern technologies such as batteries, wind turbines, you know, medical imaging, even aerospace. And students might see that this is in the what? They're just how many different minerals go into each of those usages. Is it all the same? Is it different ones? There's a kickoff point for primaries, it's a kickoff point for year 8 if they're looking at minerals there as well, or even into senior secondary when these topics are underway. Now, if you've got access, you can supplement this thinking by using real samples again. So here we have lovely piece of malachite, a piece of copper ore, and a piece of copper piping, if you know a local plumber, some copper wiring, so you can make that relationship. We've also got some pretend gold, sorry, it's not real gold, and the circuit board out of a telephone, out of a mobile phone, where you can see there's actually real bits of gold in there as well. And we've got some bauxite, and making the relationship between this, you know, brown lump of rock and our aluminium foil that we have in all of our kitchens these days. So there's ways to bring that topic alive and associate it with the resource that we've got so far. And actually, if you weren't tuned into the first session this morning, when Tamara from Geoscience Australia did a section about meaningful minerals and resourceful rocks, there was a little idea of matching up images of different sorts of materials, rock materials, with end usages as well. So after mentioning those couple of resources, they're all available to you from our web pages. As I said, you can get some of our posters as a poster pack, just email the education team here, but everything else is available online. There's a wide variety of those things, and these days we've also got some activities about using our data portals, particularly for our secondary users as well. This is one of our web pages, or it's sort of parts of it. And at the bottom there, you'll see it mentions education updates. That's our occasional newsletter. There's one more edition out this year. To become a subscriber, just click on that link and it'll take you through a brief subscription. And that way you'll be up to date with new resources or upcoming events and professional learning that we might be running or supporting. There's also some existing recordings of professional learning on our webpage and also on Karen's Virtual Excursions Australia pages under her YouTube channel as well. Coming back all the way around to students, if you are considering bringing your class to visit us here in Canberra as part of a Canberra excursion overnight or just a day trip or something like that, please, please, please book well ahead. Look at the booking system, see if there's space, and I literally mean a year ahead. There are some weeks that are already completely booked out for next year and sometimes into the following year. If you're having any difficulties, please contact us. We'll try and help you to resolve any problems that you might have. So my last sort of little message is earth science is amazing. There are so many facets to it. Teach it to your students with enthusiasm. Communicate that sense of awe and wonder that we have about the earth. And that fits into delivering the curriculum, which clearly has particular parts of it that really focus on earth sciences. I think it's almost been strengthened in the primary curriculum. And when you come to the year 8 mega unit, that's a really, really important one to deliver well and to show students that earth science has so many applications and links to other sciences as they go through their future science learning and possibly career. Thank you.
Thank you very much, Shona. Thanks for that nice quick introduction to a few resources that Geoscience Australia can offer. One thing I neglected to mention before was if you have any questions, please pop them in the Q&A. We'll get to the end of the little showcase of each of these organizations, and we'll tackle those questions as one big group all together. So if you have any questions, pop them in the Q&A. Now we're going to move across to Hannah from AusEarthEd. Take it away, Hannah.
Okay. Hi, everybody. Yeah, my name's Hannah, and I am the lead educator for primary engagement at the Australian Earth Science Education. So we call it AusEarthEd. And I joined AusEarthEd towards the start of this year, actually, and I have recently finished my PhD in volcanology. But I studied earth science in the birthplace of geology, which is Scotland. And today I'm filling in for Jo Watkins, who is our CEO, and she's currently in Onslow in the Pilbara doing some very important STEM outreach. So I will just share my screen real quick. Okie dokie. So this is AusEarthEd's website. And we've got heaps of teaching resources on our website. And we have resources all the way from foundation or kindy all the way up to year 10 in earth and space science. And then we also have year 11 and 12 earth and environmental science teaching resources. And then we also have some resources that fit more broadly within STEM. So pretty much all of our activities are really hands-on, and they've been designed so that they can be easily done using stuff that you already have lying around, places like in your kitchen or in your lab at school. So, and that's because we think it's really important to make these demonstrations really accessible and simple. So I'm going to show you a demonstration that can be found within the Earth and Environmental Science resource part of our website. So that's what I'm showing on the screen right now. And we also run this activity that I'm going to show you as one of our incursions that we do for the year 9's Earth and Space Science. So being a volcanologist, I wanted to show you a volcanology experiment or demonstration. And so this one is going to be a very simple lava viscosity demonstration. I will just stop sharing so that you can see me. And this demonstration is going to help students understand the difference between a high viscosity or sticky lava and a low viscosity or runny lava, and how these differences can also lead to different styles of eruption, such as effusive versus explosive. And it can also then, you can go into more detail related to things like the tectonic setting of these volcanoes as well. So all you're going to need for this demonstration is just some vegetable oil from your kitchen, easy peasy. You're going to need some food dye, so some different colors would be good. Usually red is good for lava. And then some Aspro Clear tablets that you can just get from the chemist. And we've got 2 glasses here. I've filled these up already. So I've dyed the water a red color, and then we also have the oil. So one of the glasses has a lot more water in it with just a little bit of oil, and then the other one has got a lot less water and a lot more oil. So this one with more oil demonstrates the high viscosity lava, and this represents something like a sticky rhyolite lava, something with high silica content. And a good analog for the high viscosity lava would be peanut butter, because if you put peanut butter on a slope, it will flow quite slowly. And the other lava is like a low viscosity lava, something representing something like a runny basalt lava flow, which has a low silica content. And a good analog for this one would be ketchup, because that one would flow down the slope pretty easily. So it's all about resistance to flow. So now I'm actually going to add my gas to each of the glasses, and this gas represents the magma. So I've got 2 Aspro Clear tablets per glass, and we're going to pop them in at the same time and see what happens to the gas as it's being released from the tablet. So 3, 2, 1, let's go. And we can see that the gas in the low viscosity lava, which has more water, is escaping really fast and easily. Whereas on the other hand, the gas in the high viscosity lava is escaping much slower. And in fact, it's got all these large blobs in it, and it looks a little bit like a lava lamp. So then once I've done this activity with the students, I usually ask them, so if we have this high viscosity magma ascending through the crust, and it's even more viscous and sticky than this, then what will happen if the pressure builds up in that magma and eventually becomes too high for that lava to cope with, or for the magma to cope with? What will happen? And the answer is, well, there's going to be a large explosion, and that lava will actually get fragmented. And this will produce something like a hot pyroclastic lava, pyroclastic flow, or a large eruption plume. And so this is one of the most hazardous types of eruptions. If the gas can escape, then there's going to be a smaller or even no explosion. So you might just get a lava flow, and we call this an effusive eruption. And these lava flows, they can come with their own hazards, but they're less hazardous than if we have fragmentation. Okay, so I will go back and I will show you where you can find this activity on our website. So if you go into the Earth and Environmental Science tab shown on the screen, and you'll see, once you've gone into that tab, you'll see a large section of topics that are within the curriculum. And if you click on the plate tectonics and geohazards section, then you'll find this worksheet. And that explains the experiment. And then there's a number of questions for the students to answer afterwards. Okay, and then I wanted to show you that we also have 2 YouTube channels. Our first channel is the Earth Science Western Australia ESWA channel. This is our older channel, and it's got lots of professional looking educational animations in there. So that's super good. And then we've got our second YouTube channel, which is our newer AusEarthEd channel. And this has got lots of homemade kitchen counter style videos, which are super simple for you to replicate yourself. So I thought I would just show you one of these videos. So another fun experiment for understanding the impact of gases on volcanic explosivity. So I will just play that for you now. Okay, there you go. I think a lot of those videos were made during COVID when there was lots of time. So yeah, lots of kitchen counter style videos there, really simple for you to do yourself. And then I just wanted to finish off by just showing you that we offer a real range of different services across Australia. And so this map gives you an idea of the different services we provide in different states and territories. And we've got people on the ground in Western Australia, Northern Territory, and New South Wales. And then I just wanted to reiterate that we absolutely love being in classrooms and out in the field, engaging with students. And so thanks to our sponsors, we provide these incursions and field trips for free. And this slide just gives you an idea of our impact over all time, although this version is slightly outdated now. But this was our impact in 2023 last year. And that's us in a nutshell. So I would be happy to answer any questions that you have afterwards. Thank you for listening.
Thank you very much, Hannah. That was really great to see. I think you called it kitchen benchtop science as well, making it really accessible. I do love that. Thank you very much. Next up, we're going to move along to Core Learning Foundation with Adam and Jet. Take it away.
G'day guys, just a quick intro on there, but before we do, can somebody please enable my video hosting? Hello? Is anybody able to hear me?
Yeah,
Okay.
we can hear
There
you.
we
Try
go.
that now.
There you go, there's your video.
There we go. G'day guys, how are we doing? My name's Jed. I'm from the Core Learning Foundation. I'm Business Development Officer here. So I am tasked with growing a wonderful impact. And my colleague who you can see is Adam Brooks. He's just come on as a new educator to, again, grow our impact to more and more schools. So Adam, could you kindly share up?
Yeah, I'm just trying to sort that out. We've had some technical difficulties at this end. Is that sharing now?
No, it's just coming through as a line.
Screen sharing. Saying my screen sharing is paused.
Oh, there it is.
Awesome. We got there.
Excellent.
Fantastic. So, to give a little bit of an introduction to the Core Learning Foundation, who we are and what we do, we were started by a very passionate geologist and educator called Susie Urbanak. And she went into the resource industry as a geologist, and she quickly realized that the content that she and skills that she was taught at university didn't carry across into the real world. And so her problem statement, I guess, was why aren't we teaching kids to be able to work in the workforce just as they would right now, rather than trying to just teach them content and not the skills. And so she started the Core Learning Foundation back in 2018. And the whole idea of it, Adam, if you can take us to the next slide, is to be bringing students in the primary and secondary space outside of a classroom that's focused on whiteboards and textbooks and conducting science in a very clinical fashion like that, and actually getting the students to be real scientists, working with projects, learning through projects, learning through field trips, investigations, all connected together to create real-world experiences, develop their STEM workforce skills, and also, quite importantly, to connect their career opportunities into the curriculum. So not only are they learning all this great stuff, they're also able to tie it to a purpose of where they can go in life, which is really important. And so we've been doing that for the last 6 years. And one of the initiatives that we've got, how we help do that, is our Gamifying Earth Science program. So, Adam, do you want to take us through a little bit of an explanation of what we do in that space?
Yeah, so thanks for having us today, and happy Earth Science Week. So today what we're talking to you about is our Gamifying Earth Science initiative. So we have two games that are based around the earth science curriculum. So we've got Resource Respond Rescue, which is a Minecraft-based game, and that's based around the concept of natural disasters and how, as a team, we can prevent them using mitigation strategies. And the second game that we've got is a game that we've developed through some game developers called AusEarthEd, and that looks at the entire rock cycle from the creation of ore all the way through to export. And so our Resource Respond Rescue is introducing students to those careers. So we identifying the emergency response team, and we're looking at a simulation of different types of natural disasters that happen. So we've got flash floods, bushfires, earthquakes, and tsunamis. And each of those scenarios are based around a different rural mining town. And as you see in the pictures there, in the glass section around those dioramas there, we've got different dioramas of those mitigation strategies, as well as lots of information regarding those particular events that are happening. So when students are actively involved in this, they're gathering information, collecting it using screenshots and taking photos, and then you're bringing that together as a class to look at how we might mitigate these situations, and then we run the scenario and see if the mitigation strategies have helped mitigate the event from happening, or whether we needed to do something more.
Fantastic. Thanks, Adam. So Adam's just explained our Minecraft game. The other game that we have, we call Old as Dirt. And what we try to do with Old as Dirt is we take all the very disconnected and disjointed concepts that we teach in earth science, and we tell them in a story. We tell them in a journey delivered through games, because that's what's engaging and fun. And so the story we tell is ore to export, and the stages of that are the formation of ore deposits into the earth, how we identify these ores and minerals for mining, setting up and running a mine, and transporting these ores off to market for their many uses in our daily lives. And so to tell this story, we've created two collaborative games per each stage. And you notice I say the word collaborative. That's because we really wanted to take the emphasis with these games away from a competitive approach, which pits students against each other and puts them into a siloed thinking mindset. And we alternatively put them into teams where the students have to work between teams and within their teams together as a class to solve the game. So, could you take us to the next slide? Here are 8 games telling this ore to export journey, and the first one in it is anoxic shock. And this game, we introduce the concept of early Earth oxygenation. Students are playing as stromatolites, and they're fighting off cyanobacteria through emitting oxygen. And then we come to our keen adventure, where student teams are different stations on a submarine searching for hydrothermal vents, and students have to use their data literacy skills to identify the conditions that hydrothermal vents make in the ocean's water, and then go and seek those locations. Outback Trail is a type of digital incursion, is the best way we can describe it, game where we have a few experts that come in and talk to the class about the flora and fauna, the indigenous landowners, and the banded iron formations of this beautiful landmass we call Australia, and the interconnection of the three. And so students get to vote their way through a conversation. Just the same, we have on cover, students vote through the conversation, but this time they're looking at discussing the different careers associated in the resources industry, and for how we identify ores and how we set up and run mines. And this is really important because we want to bring back the career connection to everything that we teach, so there's a purpose behind it. Moving to coring and exploring, student teams have to work together to identify a core sample that's just come out of the ground. The game doesn't tell the students what the core sample is, but it does give them the ability to run tests on it and provide facts. And so the students have to pass information between each other to figure out through process of deduction what mystery rock or mineral they've been given. That's personally my favorite game. Modern Mine is another one of the digital incursion games, this time looking at the career opportunities of the smart mine of 2049. So this is talking about a decarbonized world, decarbonized mine, and the roles and careers that are associated with that transition. Keep It Moving. This is now moving into the transport side of exporting these rocks and minerals. So Keep It Moving is really replicating the rail management network that we see up here in the Tom Price in the Pilbara region of Western Australia, and I'm sure there's many other rail networks across Australia that supply our economy essentially, and so the students get to play as that. And then finally, moving to Containing Chaos, students have to use their logic, sequencing and programmatic skills to correctly identify which cranes can load which crates based off specific conditions. So this is really tapping into, as I say, that logic programmatic thinking. Very, very handy for a bit of IT work in that space as well. So they're the 8 games that we tell in a story. But beyond just the Minecraft game and these 8 mini games, can you take us through the Educator Centre and the service offering that we supply in addition to that?
Yeah, so one of the key things that we will say about ourselves is we're not a bolt-on, we're a bolt-in. We're there to support you along your journey and help you out as much as you need. So the Educator Centre is the starting point for that. So this is a website that has access to teacher resources. It's got links to curriculum and ideas for extension on these activities too. It also shows you and reminds you how to connect to the games. There's video tutorials as well to upskill you and documentation there too. But the way we work is we'll run a session with you and your staff to upskill you and play the games with you yourself. And then we're happy to then come out and help you map that to curriculum for additional activities too. So once again, we're definitely not a bolt on, we're a bolt in, hand holding along that journey to innovative education that students love. And that's it from us. Once again, if you've got any questions, we'll be happy to hear them. And there are some QR codes. If you've got a second device, you can scan those to register for a demo or else check out our website to learn more.
Beautiful.
Thank you very much, Jet. Thank you very much, Adam. It's great to see the practical hands-on approach and the drawing from real-world experiences that you put into your games, with a bit of a focus on geoscience careers as well. I've definitely learned a lot about feudal Japan playing games, but that's not a career that I can go into.
I'm a games programmer by trade, so yeah, I'm with you there.
Excellent. We'll move right along. Thank you very much. We're going to hear from Philip from TESEP, the Teacher Earth Science Education Program now. So thank you, Philip.
Thank you, and good afternoon, everyone. And thanks to the other presenters who have certainly enlightened me to all the wonderful educational opportunities that students have these days for learning about earth science. I'm the Tasmanian coordinator for the Teacher Earth Science Education Program, and that has been operating now for probably close to 16 years. And our mission basically is to provide teachers with professional learning opportunities in earth science across most of the Australian states and territories. We have presenters in obviously Tasmania, where I'm from, Victoria, New South Wales, and presenters also travel to various interstate locations as well. So what TESEP does is really to ensure that teachers have a thorough understanding of earth science, as we have found that many teachers, or in fact the majority of teachers, would probably have little understanding of earth science. And so we aim to upskill them with knowledge and also to give them access to a whole range of teacher resources. So I'll take you first of all to the TESEP homepage. Which is that one there. And so we provide obviously PD workshops, which can be found under that tab there. We also provide student resources, and in all these Australian locations, we have various activities happening. So teachers just need to check in with their state to see if there is an event happening, or what is proving to be quite popular these days are webinars. And for the last 2 or 3 years, we've been running after-school webinars across a whole range of earth science topics. And in term 4, starting next week, we're going to be running a session, or 4-week session, on climate change through geological time. And so you can register for that by going into the all events section of this part of the web page. What I'm going to focus on really is the teaching resources tab up here, where we can access various things like rock kits, plate tectonic posters, and more importantly, if your school has bought a TESEP rock kit, which has proved to be very popular over the past 3 years, then you can access this through a special access code. And similarly for the mineral kits, which have just been released now, just over a month or so ago, you can access those as well. So I'm going to take you through to the latest one, which is the critical minerals kit. All of these are retailed by Haynes Education. And what we've done with the minerals kit is produce 2 packages, one of which contains the minerals that are critical and useful in today's society. And you can see the list of the minerals in the kit down here. And the other one is the ones that are much more useful in not so much a critical mineral sense, but are used in general use of minerals and rocks in society today, particularly with manufacturing. We'll have a look at those in a little while. So if I take you to the mineral kit download page, this is where you can access information if you have done one of the introductory workshops. And you can see here we have a whole range of what we're calling rock forming minerals. And so they're in one of the boxes, and in the other box we have the critical and also metallic elements that are essential for today's technological society. So these numbers just refer to the numbers they have of the mineral. There's no significance in a number. They've just been picked out at random. And then you will see a column here with S on it. That means that we have written a story about that particular mineral. So we might go to one like garnet, for example, click on the story there. And this will provide information about mineral number 63, which is garnet. It's highlighted there on the screen to show you where it is in relation to the other minerals in that box. And then we give you some information about the garnets. We're looking at, in particular, some of its chemistry, some of its geological features, and so on. A bit of information about the geological story behind garnets. and also some interesting facts that might be really useful for engaging students in that particular mineral. And then we've got some suggested questions that might be appropriate for upper primary through to secondary school students, and gives some clues as to where they might want to go with the answers to that particular question. Oops. Just get back into that. We'll go back to, say, another mineral like barite. So the barite is highlighted there in the photograph. Again, we give a bit of an information about barite, what it's used for, some information about its chemistry and basic physical features, how it occurs through a geological sense, and then again we give some questions that are suitable for the upper primary, secondary students, and give some clues as to where they might want to go with the answers for that one. So that one there, the critical mineral kit as a standalone item can be obtained from Haynes Education. The rock kit that has proved popular, we've sold well over 1,000 boxes of those. So there's 3 boxes, each one being sedimentary, igneous and metamorphic rocks. Very popular. We have a combined one now where you can purchase the whole lot, the critical mineral kit, the rock kit, and also the plate tectonic poster that brings all of it together in one bulk discounted buy. So we'll go back to the home page again. Again, all of that information is found under that Teaching Resources tab, but these ones here are the ones that you'll need to be able to access by attending a workshop where your school has actually purchased one of these kits. So we hope that the critical minerals kit is going to be as popular as the rock kit. I'm sure it will be, given the publicity associated with critical minerals these days. So I'm happy to answer any questions from the Q&A in due course. Thank you.
Thank you very much, Philip. It's always great to see the rock kits and mineral kits. We've got one of both, and it's really great. You know, it's all well and good to look at rocks on a screen, but break the fourth wall, picking up an actual rock and being able to feel the textures and the density and look at the different minerals that make up a rock is, you know, it's great. Much better than looking at a photo. I think we might get everybody back onto the screen now and we'll have a crack at some questions. For now, there's none in the Q&A. So if you have any questions, please pop them in the Q&A now. I'm going to switch over to Shona as well. I've got a question for everyone, though. We might open this one out to the floor while we wait for other questions to come through. Why is it important to support teachers in delivering earth science education? Very big question, and it's, you know, the bread and butter of what all we do here. And I said I'd open the floor, but I might single Shona out first to start first.
I think we still see a huge need. I think that's the main thing, that there's a huge need in the teaching community for support in earth science education. So many of our science teachers, let alone our primary teachers who aren't even science specialists, have experience of biology or physics or chemistry, but they have very little experience in the earth science area. So again and again, even teaching the senior courses around the country, we've got teachers who are coming in as non-experts and they need support and information. And I think we all have ways of supplying that. Unfortunately, we still hear stories of the teachers who leave the Year 8 Earth Science unit to the end of the year, to the last 3 weeks of term, and have no interest in actually delivering it well. And that's the barrier we need to try and break down. What I think we're finding even more so now than perhaps a few years ago is it's even more difficult to get teachers to engage. The teachers that aren't already, the ones that really need it, aren't necessarily the ones that are here with us today. And we're trying to get that engagement, and it's hard times for teachers in terms of getting relief and release and having the time on top of the normal workload to just do professional development. That's my thoughts to kick things off.
Well, I totally agree with you, Shona. In my travels around the country, visiting many schools and presenting to many teachers, I generally ask them how they rate their understanding and communication of earth science to students on a scale of 1 to 5, and most would be saying 1 and 2. You would rarely have a teacher rating their confidence level at being 3 or above. So it's a real indictment that that we just don't have in the education workforce these days people that have any knowledge, or little knowledge, let alone the enthusiasm to engage students.
If I can build off that, Philip, I think that's an excellent comment. And from our perspective, it's really a two-part problem. What's just being said being part one, and that teachers aren't supported in knowing how to deliver it. And the second is really probably not understanding the importance of earth sciences and why we need to teach it and students need to understand earth sciences. At the end of the day, the earth gives us the energy that we use to power our civilization. It gives us the soil that we use to grow our food, the water that we drink. All of the sciences are encompassed under earth sciences, but the bigger context is the understanding why we need to, let me rephrase that. We need to do a better job of educating teachers and the schooling system why earth sciences is actually so important, and we need to bump that up. So yeah.
Anybody else want to jump in on that one?
I mean, I wanted to just add, yeah, I totally agree with what everyone said. And the other thing is teachers might not feel that they have the equipment to teach earth science, but like it's actually super simple. I mean, as I showed, you can just grab stuff from your kitchen, and you can also pull from other subjects. Say if they've been teaching physics or chemistry, some of those equipment from those kind of topics are really transferable for earth science as well.
I'll just add that, so Susie Urbanak, the founder of CORE, is a geologist by trade. So she has that knowledge base and skill there. But part of what she does in her role with our CORE schools is helping teachers get out into what she calls # the real classroom. So getting out there, understanding the geology by looking at rocks, and then incorporating the physics behind that and the chemistry and the biology through field trips, through that connection to the earth, and actually having students there and teachers learning side by side, and upskilling in that space. So yeah, I think that actually going out there and being outside of the classroom, I think, is a key connection in getting teachers connected to what earth science is.
Thank you all for contributing to that answer there. I think one thing that I can pull out, one of the little themes there, was the intermingling of a science with every other science, and really, when you think about it, the ease to which you can teach earth science. And I think like referencing, Hannah, what you were mentioning with just stuff that you have lying around at home, I think that both really really complements the theme of earth science this year, being earth science everywhere. And it's kind of like, it is. Earth science is everywhere. You just need to look for those applications across the curriculum in other subjects, or think about the chair that you're sitting in or the piece of foil on your bench, anything like that. We just got one little comment in the chat that I'll read out because it's a lovely comment from David. My students, primary, love a great lava explosion and love sharing their rock and mineral collections as well. Yeah, great enthusiasm for students coming in and telling us all about their rock collections.
I was just going to say, the number of times, if you actually ask the question of a middle primary or upper primary class, how many of you got a collection of rocks? So many hands go up, often to the surprise of the teachers. They don't actually realise how much the kids of that age are collecting up all these bits. And of course, rocks don't mould and decay. You can keep them for longer or life.
We were at PGMS, the Perth Gem and Mineral Show this weekend, and one of the things on our stand was just some beach sand with some malachite and chrysocolla and stuff mixed in, and with some tweezers, and the students were fossicking. What minerals do you see? And you see some green, you see some teal, you see some there was some azurite in there, some blue. And that was like one of the favorite parts of for kids in this whole show was just being able to fossick for rocks. So simple.
We've got a question here from Claire. This is for Geoscience Australia. Shona, can you request specific posters to be sent out, or is it general poster packs that you send out?
You could, of course, you could request specifics, but you may not be able to tell which ones we've actually got prints, because online we've got a larger suite than we actually have in print. So we could send you sort of one of each, but correspond with us by email. And if there's something specific you'd like, we will absolutely let you know if we can supply that. But yeah, we can adapt, definitely.
That pretty much brings us to time. No other questions in the Q&A. If you have very fast fingers within the next 10 seconds, then you can pop a question in. Otherwise, I'd just like to invite you all and join me in thanking Hannah, Jet, Adam, Phil, and Shona for being so generous with the knowledge and the resources that you've shared this afternoon. Thank you all for coming. Have a happy Earth Science Week. Karen, back to you.
Thank you so much for facilitating that conversation, Dom, and thank you all for joining us today. So much wonderful information that you've been able to share. Really great simple experiments, great online resources, the gamification, all of those are really useful in that toolkit of resources for teachers. So a really great complementary set of resources. And I've got links to all of your websites in the follow-up information that will go with the recording to all the participants that have joined us today and all the ones that registered that weren't able to attend in person. So thank you all very much. A big thank you again to Geoscience Australia for supporting the entire Earth Science Week virtual excursion day. It has flown by. 6 back-to-back sessions. It has been absolutely incredible. So, and a really great way to finish it up to help teachers and parents support their students and children's learning. Because as all of you said, it is really important for us to understand earth science. And I would like to own up. I'm one of those children that started with a rock collection. So when I go out and talk to students about rocks, I will actually own up that I started my rock collection when I was 4 years old. I won't tell you how long it's been going for, but quite some time. And it has grown dramatically from the nice smooth river pebbles that I used to pick up as a child to slightly fancier. But yeah, really important part of that idea of collecting as well, that children just innately want to do. So excellent. Thank you all so much for joining me today. And I look forward to next year, 2025. So thank you again. Bye, everyone.
Bye.